Have you ever wondered if our universe is truly unique and one of a kind? Or could it be just one small bubble floating in a vast ocean of parallel realities? The idea of the multiverse, the possibility that our cosmos is not alone, but instead exists among an unfathomable ensemble of other universes, has captivated scientists, philosophers, and imaginative thinkers for centuries. In this intriguing exploration, we'll dive headfirst into the mind-bending realm of the multiverse, unraveling the various theories that propose its existence and grappling with the profound implications they hold. From infinite realms where every possibility plays out, to cosmic recycling plants churning out an endless supply of new universes, we'll navigate the frontiers of modern cosmology and physics. But the multiverse is more than just a fanciful notion. It arises from serious scientific theories that seek to reconcile the paradoxes and unexplained phenomena of our universe. Could parallel worlds be the key to resolving some of the deepest mysteries of existence? And if they do exist, how might we ever gather evidence to prove it? So open your mind, stretch your imagination, and get ready to embark on a journey that transcends the boundaries of our known reality. The multiverse awaits, and the possibilities are as vast as the cosmos itself. The origins of multiverse theory. The concept of multiple universes existing alongside our own is not a recent flight of fancy. It has roots that stretch back centuries, emerging from the musings of brilliant thinkers grappling with the nature of reality. In the 17th century, the philosopher Gottfried Leibniz proposed the idea of a plurality of worlds, arguing that our universe must be just one of an infinite series of possibilities created by an infinitely powerful and benevolent God. This notion, although rooted in theology, planted the earliest seeds of multiverse theory. Fast forward to the 20th century, and the multiverse gained traction from an unexpected source: the peculiar world of quantum mechanics. The Copenhagen Interpretation, proposed by Niels Bohr and Werner Heisenberg, suggested that reality exists in a superposition of multiple states until it is observed, at which point the wave function collapses into a single outcome. This bizarre principle led to the idea of parallel universes branching off, with each universe representing a different possible outcome. Meanwhile, cosmologists were struggling to explain the startling homogeneity of our universe on a large scale, as well as the precise fine-tuning of the fundamental constants that make life possible. This sparked the idea of a multiverse of universes, where our universe is just one of an infinite ensemble, each with slightly different laws and constants, a cosmic lottery that happened to produce the conditions suitable for our existence. From these diverse origins, modern multiverse theories have blossomed, each offering a unique perspective on the nature of reality and the possible existence of parallel worlds. Quantum multiverses. At the heart of quantum mechanics lies a profound mystery: the measurement problem. When we observe a quantum system, we seem to force it into a definite state. But what causes this wave function collapse? And what determines the outcome we observe? One interpretation, proposed by Hugh Everett III in 1957, suggests that there is no collapse at all. Instead, Everett's many worlds interpretation posits that every possible outcome of a quantum measurement occurs, but in separate, parallel universes that branch off from each other. Imagine a simple experiment with a single particle that can spin either clockwise or counterclockwise. According to Everett, when we measure the particle's spin, the universe doesn't randomly choose one outcome. Instead, it splits into two parallel universes, one where the particle spins clockwise and another where it spins counterclockwise. In this mind-boggling concept, every quantum possibility is realized, and an infinite multitude of parallel universes constantly branch off, creating a vast, ever-expanding multiverse. But the implications go far beyond quantum experiments. If the many worlds interpretation is correct, then every decision you make, every thought you have, spawns an entire new universe where the alternative possibility played out. There could be a universe where you chose a different career path, another where you never met your significant other, and countless others where history unfolded in radically different ways. While the idea of an infinite multiverse arising from quantum mechanics may seem outlandish, it offers a compelling solution to the measurement problem and aligns with the inherent probabilistic nature of quantum theory. And as we'll explore later, there may be ways to gather evidence for or against this incredible proposition. Cosmic inflation and eternal inflation. Another major driver of multiverse theories comes from our current understanding of the early universe and the phenomenon known as cosmic inflation. According to this widely accepted model, the universe we observe today emerged from an incredibly brief period of exponential expansion mere fractions of a second after the Big Bang. During this inflationary epoch, the universe grew from a minuscule, subatomic speck to a vast, smooth expanse larger than the observable cosmos we see today. This rapid expansion not only explains the remarkable uniformity of the universe on large scales, but also accounts for the tiny quantum fluctuations that seeded the formation of all the stars, galaxies, and large-scale structures we observe. But what powered this incredible burst of expansion? The leading theory suggests that it was driven by a peculiar type of energy inherent in the fabric of space itself, known as the inflaton field. This field, much like an air-filled balloon being inflated, exerted an outward pressure that caused space to stretch at an exponential rate. Here's where the multiverse comes into play. According to eternal inflation theory, first proposed by physicist Alex Vilenkin, the inflaton field didn't just drive a single burst of inflation. It continuously spawned new pockets of inflating space, each with slightly different properties and physical laws. Imagine the inflaton field as an eternally frothing ocean, with bubbles of space-time constantly forming, inflating, and giving birth to new bubble universes, each with its own unique characteristics. In this cosmic bubble bath, our observable universe is just one tiny, inflated region within this vast, eternally expanding multiverse. But there's more. Within this infinite sea of universes, some regions may have different effective laws of physics, different fundamental constants, and even different numbers of dimensions. The cosmic landscape of possibilities is truly mind-boggling, with realms that could be vastly different from our own, or perhaps even hospitable to forms of life we can scarcely imagine. While the idea of eternal inflation remains a theoretical construct, it arises naturally from our current understanding of the early universe and offers a compelling explanation for the apparent fine-tuning of the cosmos. By postulating an infinite multiverse, the seeming improbability of our universe's existence becomes a natural consequence of exploring all possible realities. String theory and higher dimensions. Among the most ambitious attempts to unify all the fundamental forces of nature into a single, coherent framework is string theory. This revolutionary concept proposes that the basic building blocks of reality are not point-like particles, but rather vibrating, one-dimensional strings existing in a higher-dimensional space-time. While string theory initially aimed to reconcile quantum mechanics with Einstein's theory of gravity, it soon revealed a startling possibility: the existence of extra, unseen dimensions beyond the three spatial dimensions and one time dimension that we experience. According to string theory, our familiar four-dimensional universe could be just a small slice of a higher-dimensional reality, like a three-dimensional sheet floating within a larger, higher-dimensional space. And if extra dimensions exist, they could open the door to a whole new kind of multiverse. One intriguing idea, known as the brain world scenario, suggests that our universe may be confined to a three-dimensional membrane or brain floating within a higher dimensional space or bulk. In this scenario, other brains could exist parallel to our own, each containing a separate universe with its own laws of physics and dimensional structure. But it gets even wilder. These parallel brain universes could potentially collide or pass through each other, leaving behind imprints or defects in the fabric of space-time that we might one day observe. Some theorists have even speculated that the Big Bang itself could have been the result of such a cosmic collision between brains in a higher dimensional multiverse. While string theory and higher dimensions remain speculative and incredibly complex, they offer a tantalizing glimpse into the possibility of a multiverse existing beyond our three-dimensional reality. And as our understanding of these theories deepens, we may uncover new ways to explore and potentially test their bold predictions. Simulated universes and the multiverse. As our technological capabilities continue to advance at an exponential rate, some scientists have proposed a radical idea. What if our entire universe is actually a highly advanced computer simulation akin to a cosmic video game or virtual reality? This mind-bending concept, known as the simulation hypothesis, has profound implications for the nature of reality and could even suggest the existence. The simulation hypothesis rests on the assumption that if a civilization can develop powerful enough computing capabilities, it would inevitably create highly detailed simulated realities, potentially populated by self-aware beings just like us. And if this is possible, then there could be vastly more simulated universes than actual physical ones. This line of thinking leads to a startling conclusion. We could be living inside one of these simulated realities ourselves. Our entire cosmos, with its precisely tuned laws and constants, could simply be a staggeringly complex computer program running on some advanced civilization's supercomputer. But the simulation hypothesis takes on an even more profound dimension when considering the idea of nested simulations, simulations within simulations. If our universe is a simulation, there's no reason why our simulators couldn't run multiple nested simulations themselves, essentially creating a multiverse of simulated realities within their overarching simulation. And if we dig even deeper, each of those nested simulations could, in turn, contain their own hierarchies of simulated multiverses, creating a fractal-like cascade of realities within realities. The implications are staggering. Our universe could be just one tiny bubble in an infinite sea of nested multiverses, each hosted within the digital confines of a higher-level simulation. While the simulation hypothesis may sound like science fiction, it has gained traction among serious physicists and philosophers who argue that it may be impossible to definitively rule out the possibility that we live in a simulated reality. And if true, it could provide a framework for understanding the nature of multiple universes and the structure of reality itself. Testing the multiverse, exploring the possibilities. So far, we've delved into the various theories that propose the existence of a multiverse, each offering a unique perspective on the nature of reality and the potential for parallel worlds. But as intriguing as these ideas may be, they beg the question: how could we ever gather evidence to support or refute the multiverse hypothesis? While the challenges are formidable, scientists have proposed several intriguing avenues for potentially detecting signatures of other universes or testing the predictions of multiverse theories. Let's explore some of these possibilities. 1. Cosmic microwave background radiation. The cosmic microwave background radiation, CMB, is a faint glow that permeates the entire universe, a relic of the Big Bang's intense heat. Remarkably, this ancient light carries imprints of the universe's earliest moments, offering a window into its primordial conditions. According to some multiverse theories, particularly those involving eternal inflation, our universe may have collided with other bubble universes in the distant past, leaving behind telltale patterns or anomalies in the CMB. By studying the CMB with unprecedented precision, scientists hope to detect these cosmic bruises, which could provide evidence for the existence of other universes. 2. Quantum entanglement and wormholes. In the realm of quantum mechanics, the phenomenon of entanglement allows particles to become inextricably linked, even across vast distances. Some theorists have proposed that entanglement could potentially connect particles across parallel universes, creating a kind of quantum wormhole between realities. If such wormholes exist, it might be possible to detect their presence by carefully studying the behavior of entangled particles. Deviations or anomalies in their behavior could hint at influences from other universes, providing tantalizing evidence for the many worlds interpretation or other quantum multiverses. 3. Cosmic strings and defects. According to string theory and higher dimensional models of the multiverse, our universe could be just one of many brane worlds existing within a higher dimensional space. If this is the case, the collisions or interactions between these parallel brane universes could leave behind cosmic strings or defects in the fabric of space-time. By studying the cosmic microwave background and the distribution of matter in the universe with unprecedented precision, scientists may be able to detect the telltale signatures of these strings or defects, providing evidence for the existence of higher dimensional realms and parallel brane worlds. 4. Simulated universe tests. If our universe is indeed a simulated reality, there may be ways to detect the underlying computational grid or limitations of the simulation itself. Some proposals involve searching for quantized behavior or inherent computational constraints at the smallest scales of space-time, which could be artifacts of the simulation's digital nature. Other ideas involve looking for statistical anomalies or correlations that might arise from the simulation's computational algorithms or resource limitations. While these tests are highly speculative, they offer intriguing avenues for potentially revealing the simulated nature of our reality and the existence of a higher-level multiverse. 5. Anthropic principle and fine-tuning. One of the strongest motivations for the multiverse hypothesis is the apparent fine-tuning of our universe's fundamental constants and laws, which seem exquisitely calibrated to allow for the existence of life and complex structures. This has led some physicists to invoke the anthropic principle, the idea that our universe appears fine-tuned because if it weren't, we wouldn't be here to observe it. The multiverse offers a compelling explanation for this conundrum. If there are infinite universes with varying laws and constants, it becomes statistically inevitable that at least one universe would have the right conditions for intelligent life to emerge and ponder its existence. While not a direct test, the continued exploration of the universe's fine-tuning and the search for a deeper theoretical framework that explains it could provide circumstantial evidence for the existence of a vast cosmic landscape of parallel universes. It's important to note that while these approaches offer tantalizing possibilities, detecting evidence of the multiverse remains an immense challenge, and any potential signals or anomalies would need to be scrutinized with the utmost rigor and skepticism. Nevertheless, the quest to understand the nature of reality and the possibility of parallel worlds continues to drive scientific exploration to ever greater heights. The philosophical and cultural impact of the multiverse. Beyond its profound scientific implications, the idea of the multiverse has captivated the human imagination and sparked intense philosophical and cultural discussions. The notion of parallel realities challenges our fundamental assumptions about the nature of existence and raises provocative questions about identity, choice, and the fabric of reality itself. One of the most intriguing philosophical implications of the multiverse arises from the many worlds interpretation of quantum mechanics. If every possible outcome is realized in a separate universe, does this mean that free will is an illusion? Are our choices and decisions truly meaningful if every alternative also plays out somewhere else in the multiverse? Some thinkers have argued that the many worlds interpretation undermines the concept of individual identity, as there are infinite versions of ourselves existing across the multiverse, each with slightly different experiences and choices. This raises deep questions about what truly defines our sense of self and consciousness. On the other hand, proponents of the multiverse counter that the sheer vastness and diversity of parallel realities only amplifies the profundity of our existence. In a cosmos where every possibility is realized, the unique path we navigate through the multiverse becomes all the more remarkable and precious. The multiverse has also captured the popular imagination, inspiring countless works of science fiction, speculative literature, and creative expression. From the parallel timelines of classic tales like The Garden of Forking Paths by Jorge Luis Borges to the mind-bending cinematic journeys of films like Everything Everywhere All at Once, the multiverse has become a fertile ground for exploring the limits of human experience and the nature of reality itself. But the allure of the multiverse extends beyond mere entertainment. It touches on our deepest existential yearnings and our desire to comprehend the true scope of existence. The idea that our universe may be but a single thread in a vast cosmic tapestry of realities challenges us to expand our perspective and embrace the profound mysteries that lie beyond our current understanding. As we continue to grapple with the multiverse and its implications, it is clear that this concept transcends the boundaries of science, philosophy, and culture, inviting us to confront the fundamental questions of our existence and our place in the grand cosmic scheme. In this epic exploration of the multiverse, we ventured to the furthest frontiers of modern cosmology and physics, grappling with mind-bending theories that propose the existence of parallel worlds beyond our own universe. From quantum realms where every possibility plays out, to eternal cosmic inflation spawning an infinite sea of bubble universes, to higher dimensional brain worlds and nested simulations, the multiverse offers a tantalizing glimpse into the true nature of reality. While the challenges of detecting evidence for these parallel realities are immense, the quest to understand the multiverse continues to drive scientific exploration and challenge our fundamental assumptions about existence. The potential rewards are profound. The multiverse could hold the key to resolving some of the deepest mysteries of our universe, from the paradoxes of quantum mechanics to the apparent fine-tuning of the cosmos for life. But the implications of the multiverse extend far beyond the realms of science, touching upon profound philosophical questions about the nature of reality, identity, and the limits of human experience. It has captivated the popular imagination, inspiring countless works of creative expression and challenging us to confront our deepest existential yearnings. As we stand at the precipice of this vast cosmic frontier, the multiverse beckons us to embrace the unknown, to push the boundaries of our understanding, and to contemplate the true scope of existence. Whether it is ultimately proven or disproven, the journey to unravel the mysteries of the multiverse will undoubtedly reshape our perspective on reality itself, revealing new depths of wonder and awe in the cosmos we call home. So let us embark on this grand adventure with open minds and boundless curiosity, for in the infinite expanse of the multiverse, the possibilities are as vast and wondrous as the human spirit itself. The quest for understanding has no limits, and the multiverse may hold the keys to unlocking the greatest secrets of our existence.